Hello everyone. In this video we'll be discussing about atmospheric reflection, one of the very important topic of this chapter, that is human eye and colorful world. Before going to this, we will quickly revise the term refraction. What is refraction? As we have already learned this concept in chapter 10, that refraction means when the light ray travels from one medium to another medium, the path of the light ray changes because of the density of the different mediums. Different mediums have different densities, and because of that one, the light ray changes its path, and that is known as refraction. So what is atmospheric refraction? Next we'll see. Here you can see, consider this is our earth, and around the earth we have our atmosphere. Okay, so what is atmosphere? In social science or in general knowledge, we know that what is atmosphere. So around the earth or around the globe, we have some form of gases are there, and these layers of gases are together known as atmosphere. So here in the atmosphere we have different types of gases, and along with the gases we have so many other types of things like water vapor, we have the dust particles, and so many other stuffs are there, and these are collectively known as atmosphere. So in compared to the region above the atmosphere is thicker, and in the atmosphere all the layers are not same because different types of gases in there, and different gases have different mass and their density is different. So atmosphere is not same in all the places, or the density of the atmosphere is not same in all the places, but in compared to the outer side of the atmosphere is denser. So when a light travels from our space, like sun, stars and other things, when the light travels, a refraction takes place because of the dense atmosphere, and that is known as atmospheric refraction. So the refraction that takes place because of the atmosphere is known as atmospheric refraction. So we can define it in a better way, like the refraction that takes place because of the atmosphere present around the globe or around the earth is known as atmospheric refraction. Okay, next we'll see. Here you can see we have the atmosphere, and because of this atmosphere the light that travels bends in each of these layers of the atmosphere, and that is atmospheric refraction. Next, the big question is that why the stars twinkle. Here you can see the stars are twinkling. Here you can see, if you observe it carefully, the stars are twinkling. So if you observe the sky closely, we can see the stars are twinkling. Why it happens? Why does it happen? So this happens because of atmospheric refraction. So this is the normal position of the star, that actually it is the main position or real position of the star, but when the light travels from the star, it gets refracted at many places because of the atmosphere, and due to this reason the light comes to our eye in such a way that we see the star in a different location. So here we will see the position of the star. The apparent position means where we see the star, where the real star is not there, but where we see the star, this is known as the apparent position of the star, and we see the star here. But why does it twinkle all the time? So this is because the stars are located millions of kilometers from our site or from our earth, and because of that the light travels, and because of the different densities of the atmosphere, the things keep on changing. So once we will see the star here, again when the light will come, the reflection will take place less or more because of the density of the air, which changes because of the winds that blows, and because of the wind sometimes in a layer we have more air, and another layer in another region less air is there. So because of these all reasons, we see the stars in not in a single position. Sometimes we will see here and there and here. Because of these things, the stars changes its position continuously, and we do not see the change in position because it is located millions of kilometers from our site, and because of this one we feel that the star is twinkling, but actually the stars do not twinkle. the stars remain at one position, and because of all the atmospheric refraction, we see the star is twinkling. So it's very simple and very easy to understand this concept. Next, advanced sunrise and delayed sunset. So two things are there: advanced sunrise, and here it should be delayed sunset. So here, if you consider this, in the case of sunrise, we have a imaginary line along this earth, and that is known as horizon. So here you can see, if we stand at some places like in a beach, so we can see that there is end, and that is known as horizon, or horizon, we can say anything. So this is the horizon, and there, when the sun comes to this position, and when it goes, consider here it is, we are considering for this sunrise. So the sun is coming up from this way, and when it comes here, the light starts reaching to our eyes because of the atmospheric reflection. Actually, we are a human being is present here, and the light travels in such way that it should go in this way. A person should not see the light, because the light is traveling in a straight line, but because of the atmospheric refraction, the light gets bent and it reaches to the eye of the human, and he sees the sun in this position. So for him, the sun is appeared to here, but actually it is located in this position. This is the apparent position of the sun, and this is the real position of the sun. But because of atmospheric refraction, the person is seeing the sun in this position. So it is approximately 2 minutes. Means after 2 minutes the sun will come here, and the person will see the sun 2 minutes earlier than the actual sunrise. That's why it is known as advanced sunrise. We see the sun during the sunrise. It is not the actual sun, it is the image of the sun that we see, that takes place because of atmospheric refraction, and we see the sun 2 minutes earlier than its real time. And in the case of delayed sunset, the position of the sun is here. The sun goes down the line, or horizon line, but the light travels, and because of atmospheric refraction, the person standing on earth sees the sun here, but actually the actual position of the sun is below the horizon. But because of the atmospheric refraction, the person sees the sun just little above the real position of the sun, and that is the apparent position of the sun, and it is approximately 2 minutes. So the sunrise, 2 minutes, we see the sunset 2 minutes delayed because of this atmospheric refraction. And this is all about the atmospheric refraction and the phenomenon that takes place, or the events that takes place because of atmospheric refraction we have seen here. So mainly two things are there, that advanced sunrise and delayed sunset, and the twinkling of stars. These two events of nature can be explained with the help of atmospheric refraction. So if you have any kind of confusion in this particular concept, you ask me. I am here to help you, and thank you for watching the video.